All right, so hopefully everything is all fixed up now. Part 2. So we've already talked about how to do uniform distributions. Let's talk about what about normal distributions, right? So uniform is pretty easy. You can just find the area, but what about if we have a normal distribution? So if we have a normal distribution, let's say we want to figure out this area, right? How the heck can we figure out what that area is? Well, first off, right, if you notice, this goes forever. So this is literally an infinite amount of area that's going. That just keeps going on and on and on. For another thing, this top part is decreasing throughout, right? So there's not going to be an easy like length times width scenario here. So how can we figure this out? Well, short answer, we don't. Luckily, the calculator can do it for us. And even before the calculator, we still didn't really do it. We just had tables to do it for us. So this is going to be very important that you are paying attention, that you're watching these videos. Congratulations. Thank you for watching this video, because a lot of this stuff is not going to be talked about on any of the help, right? The help is going to give you tables, and these tables are awful, and I'm not going to give them to you, right? So gross. Don't worry about the tables. We're all going to be doing the calculators. So make sure that you're downloading those calculator sheets. That way you definitely know how to do all this stuff. So the only hard part about this, since our calculator is going to do all of it for us, right? The only hard part about this is knowing how to make these graphs. So I would suggest always graphing a normal distribution when we have these. And basically the hardest part is knowing where the data values go and where the probabilities go. So if we are graphing a normal distributions, we've already kind of done this a couple of times in class. So first thing, where does the mean go? Where does the mean go on a normal distribution? Hopefully you said in the middle, because that is correct. So we can do population mean, so mu. So the important thing, down here is where all of the data values are. Where are the data values? Down here. The data values are down here. Where are the data values? Down here. One more time. Where are the data values? Down here. Where are the data values? I lied. One more time. Down here. That's really important. Knowing that the data values are along the bottom of the horizontal line. The data values are down here. That's super, super important. Because we're talking about the areas, right? Remember, another word for area is probability. So the probabilities, like they were on the other chart, right? That other example, the probabilities are the areas. So this is going to be the regions under the curve. So this up here is our probability. So data values, where are they? Where are the data values? Down here. Where are the probabilities? They are up there. Probabilities or data values down here, probability up there. Where's the probability? Up there. Where's the probability? Up there. Data value down here. Data value down here. Probability up here. All right, hopefully we figured that out. That's really the hard part. Because we are dealing with two different number systems, right? There's data values, there's probability. As long as you know where those go and you know what functions to use in the calculator, that should not be, that's the only hard part, knowing how to actually graph them. All right, so let's actually try to figure it out. How to find probabilities for known data values. So it is literally going to say either find the probability or what is the probability or percentage, right? So step 1, identify the location of the data value, placing it in the region, placing it in relation to the mean, right? So, yeah, we can keep going. Yeah, basically, if you know where the mean is your value to the left or to the right of the mean? If it's to the right, then we make sure it's on the right side. To the left, we make sure it's the left side, right? Cool. Next, we want to shade the desired region. So remember, at most versus at least, right? At most means that that's the most, right? So that's less than or equal to. And if it's at least, that means that that value is the least. So it's that number or above. Greater than or equal to. You don't need to know the words. If these words are confusing, don't worry about it. You just need to know what that sentiment is. So we need to make sure that we're shading everything we need to shade. So what we're going to use is we're going to use normal CDF. So if you go on your calculator sheet, you should see the way to get there, right? It's going to be second vars, which is distribution, I believe. The second one is going to be normal CDF. Now, if you notice, the first one is normal PDF. We never use normal PDF. So if you haven't done any of the homework on the test, I'm going to know, they didn't do any of the homework. They use PDF. We never use PDF. It's always CDF. And you should see that these values are listed. So lower, upper, mu, sigma, right? The lower is just going to be the smallest value in your region. The upper will be the largest value in your region. The mu is, of course, the mean. Sigma is standard deviation. Now, if you don't have this, if all you see when you type into your calculator is normal CDF, these are in order. You do your lower, you do your upper, you do your mean, and you do your standard deviation. Make sure you include that negative, or the comma. Comma is above the 7. So make sure that you do that. If there is no smallest value, then basically it just goes on forever, right? To negative infinity. So since negative infinity doesn't exist, we can just write a really big number that's negative, negative 9999. Likewise, there's no largest number. Essentially, it's infinity, right? But since we can't do infinity, we just pick a really big number. Positive 9999. Oh, I'm going to get my calculator. Just make sure I didn't tell you anything wrong. Yep, second bars. Good. All right. So let's look at some examples. So example 3. A random variable is selected from, that should be from, a standard normal distribution. So standard normal, what does that tell us? That means we're talking about z-score, which means that the mean is 0 and the standard deviation is 1. You need to know that. All of that's important. Mean is 0, standard deviation is 1. Good. So find the probability that x is less than 1.27. So remember, x is a random variable. So what's the probability that a random person is less than 1.27? So first, let's draw our graph. We said the mean goes in the center. So for standard normal, we know the mean is 0. So step 1, where's our value? So this is our value right here, 1.27, right? We want to find the probability. So 1.27 is going to be to the right, right? And it goes down here because that's what the data value is, down there. Step 2, shade in the region. So if we want x is less than 1.27, are we going to be shading to the left, to the right, or in between? Hopefully you remember that's going to be to the left, right? Everything is less than it. So all of that area. Which makes sense, right? Because the thing that we want is the probability. Probability is up here. So the question mark, the blank space that we have, should be up here because that's the probability that we want, right? So in our calculator, we're going to type normal CDF. So what's the lower? We see that the lower is of this area, the smallest number. It just goes on forever. So that's negative infinity or negative 9999. What's the upper? So in this region, the biggest number is 1.27. The mean is 0. Standard deviation is 1. Right? And again, for partial credit, this is perfect for partial credit. Just writing this out, this tells me everything I need to know, right? So when we type all of that into the calculator, we end up seeing that we get there we go. So we should end up with 0.8980. So for When we're finding probability, typically we use 4 decimals for normal. So again, you don't really need to worry about that. I'll let you know one way or the other. And if I don't tell you on the test, obviously you can do whatever you want, right? But homework typically just tells you what decimals. And that's it. We're done. That was it. So let's do it again. So now let's find the probability that x is greater than negative 1.0. So make our graph. We're still in standard normal. So 0, negative 1. So step 1, find the location. It's to the left, and it's a data value. So it goes down here. Data values are down here. Then we do the shading. Step 2. Since it's greater than, we want to shade everything to the right, right? All of these numbers are bigger than negative 1. And so this whole shaded area is what we are trying to find, which is good because this is probability. Probability is up here. We know we're probably doing it okay. So in our calculator, we'd go to normal CDF. The lower, the smallest number is negative 1 in that area. You can do negative 1, negative 1.00, whatever. Goes all the way up to positive infinity, so positive 9999. The mean is 0, standard deviation is 1, right? Again, perfect for partial credit. And then when we type that into the calculator, we should get 0.8413. 0.8413. All right. Part C, find the probability that the score is between negative 1.00 and negative 2.50. So right there in the middle, right, we get 0. So negative 1 is going to go to the left of that. Negative 2.5 is going to be even more negative, so even further to the left. Since we want it in between, we shade in between. And this is the area we want, which is good because we want probability. That's our blank spot. We know we're doing it right. So we're going to type in normal CDF. The lower is negative 2.5, right? That's the smaller number. The upper is negative 1.00. The mean is 0. Standard deviation is 1. When we plug all that into a calculator, we should get 0.1524. And that's our final answer. All right, part D. Hopefully all these are doing okay. So, what's the probability that x is greater or equal to 0? So we get 0 right in the middle. So we want to shade everything. Our data value is 0, so cool, we already wrote that. So we want to shade everything. Let's shade everything to the right because it's greater than or equal to. So this is what we want. So into normal CDF, because we want probability, the lower is going to be 0. The upper is going to be 9999, yep, infinity. The mean is going to be 0. Standard deviation is going to be 1. So what do we get? 0.5 or 0.5000 if you want to write 4 decimals like that. But 0.5 is perfectly fine. Could we have done that without doing normal CDF? Could we have figured out what this probability was without doing normal CDF? And actually, yes. So some of y'all are going to hit your foreheads when you see this. But if you notice, a normal distribution, remember, normal means that it is symmetrical on both sides. So if we are at the mean, what percentage is the right side? The right half even. Doesn't it make sense? This is just 50%. Yeah, so we didn't actually have to type everything in. It was just 0.5. Which, this is a really good thing because this can definitely help us kind of check ourselves real quick, right? So if it goes beyond the halfway point, it should be bigger than 50%. If it doesn't, it should be less than it. So we check, let's, for instance, part A, right? So we can see that we have shaded in more than half, right? More than this line. So it should be bigger than 50%, which our answer is. So we probably did it right. Same thing with part B, right? We have done more than half, so we should be more than 50%. Definitely more than 50, so we know we're probably good. So again, these are very easy ways just to double check yourself, just to make sure you're doing it right. Over here, we see that this is actually less than half, right? Half would be this whole part. Since it's less than half, it should be less than 50%. And oh yeah, this is way less than 50%. So we probably did that one right. Good. All right, hopefully this all makes sense. Now we're just gonna do the opposite. And after, we'll do a couple examples and then we'll do some word problems. And the word problems for these are not hard. They shouldn't be hard at all. All right, so now we're gonna do the exact opposite. So find the data values from known, and that should say probability. So my bad. I'll make sure to change that in the future. So finding data values from known probabilities, I guess. Yeah, known probabilities. So you're given a probability and you want the data value, so it's literally the exact opposite. So first, choose the correct side of your graph. So if it is the top percentage, what we want to do is we want to convert it to a bottom percentage by what? So let's think about this. If you're in the top 5% of your class, what percentage of people are you smarter than? 95%, right? So another way to do that is 100% minus 95%, which is just 5%, right? So you can figure that out by subtracting from 100%. And since we're always going to do this, I mean, there's other ways of doing it. So if you have another professor who told you a different way and you like that way, that's totally okay. But I feel like from what I've seen with students, this is the best way to minimize errors. So just always doing a bottom percentage. And since you're always doing a bottom percentage, the side we're starting with is the left side. We're coming from the left every time because the bottom would be the left side, right? Negative infinity. All right. Part two, if the percentage is below 50%, so if we got our mean and it's below 50%, which side should this end up being on the mean? Should it be to the right side? Well, if you're coming from the left, no, that's more than 50%, right? If you're coming from the left and go up to the mean, that's 50%. So if it's less than 50%, right, then the area won't go past the mean. If it's above 50%, right, you go up to the mean, then it should go past it, right? It will go past the mean. So mark the value and shade the area from where you came from. So if we came from the left, which we always will because we're always in the bottom percentage, you're just always going to shade to the left. So what we use for this part, it's inverse norm. Literally the inverse of what we just did, right? And again, you can find that from second VARS, and there'll be number 3. Now, here we go. Area, mu, sigma. So everybody should write this down. This is super important. It is not just area. It is important area. It is the area to the left. Area to the left. Where is it? To the left. Where is it? To the left. Think Beyonce, right? To the left, to the left. Which also happens to be the bottom percent. So as long as you followed everything I said, right, that's going to be easy. You don't have to think a second thought, right? The area is whatever you were given. Or whatever that bottom area is. That's what you're going to type in. So as long as you followed my steps and always make sure you always do the bottom percent, then that area is just going to be whatever that bottom percentage is. Then you type in the mean for the mu, standard deviation for sigma. All right, so let's look at example 4. I thought we were on example 3. Nope, we're on example 4. Cool, cool, cool. All right, so find the z-score separating the top 36%. So z-score, what's our mean and standard deviation? So hopefully you said that the mean is 0, standard deviation is 1. That's what the definition of a z-score is. So first thing we need to do, top is bad, so figure out what the bottom percentage is. So we can just do 100 minus 36, we end up with 64, right? So this is the bottom 64%, and that's what we're going to graph. So what goes in the center? 0, right? Remember, this is down here. These are the data values, and now we have a percentage. So all this stuff's going to be the area up here. We're not really worrying about 0 anymore. We're worrying about the area. So we come from the left. So at the halfway point, what percentage have we gone? We've gone 50%. Is that too far or not far enough? Well, we want 64, so that's not nearly far enough. So we've got to keep going, right? So it's going to be on this right side. And notice, this is not going to be where the 64 goes, right? Because what goes down here? Data values. Is 64% a data value? No, it's a percentage, right? So the percentage goes up here. And since we came from the left, we're going to shade to the left. And this is our 64%, or if you put in a probability, 0.64. And this is what we need to find, which is good, right? What is the z-score? That's what's the data value. So just like earlier when we wanted the probability, the blank spot was up in the probability area. But now we want a data value, so the blank is down here. So we know we're doing it right. So since we want a data value, since we want a z-score, we type in inverse norm, excuse me. The area, since we did the bottom percentage, we know the area is 0.64. The mean is 0, and the standard deviation is 1. So again, this is perfect for partial credit, right? Just typing all that stuff into your calculator. So what we get is 1.645. That's our z-score. Now, does that make sense? Does it make sense for us to put 1.645 right here? What is that in relation to the mean? We see it's above, it's positive, which is good. It should be above the mean. So we probably did that right. So that can be another just quick way to double check yourself. Does it make sense for this value to go right there? And yeah, it does. Let's do another one. All right, so part B, find the z-score separating the bottom 91%. So we already have the bottom percentage. Good, we don't need to do anything else. So we need to do anything extra. So we just put the mean of 0, because that's what our z-score is, right? So 91%. We're coming from the left. If we go up to the mean, how far have we gone? Too far or not far enough? Well, we've gone 50%. That's not nearly far enough. We need 91, so we keep going. It doesn't really matter where you put that line, just as long as you have it correctly. Since we're going to shade in the area to the left, because that's where we came from, right? So where is the 91% going? Is it going up here, or is it going down there? So remember, the percentage probability goes up here. So that's where the 91% goes. This is what we're trying to find. That's really the hardest part of this, knowing where that 91 goes, up here or down there. So since we're trying to find a z-score, we're doing inverse norm. Area to the left, since we did bottom percentage, we know it's 0.91. The mean is 0. The standard deviation is 1. So when we plug all that into our calculator, oh, I'm so sorry. The last one was not, oh, I'm so sorry. Yeah, the last one was not 1.645. No. That was something very different. Okay, so if you were yelling at me, you were right. Yeah, you should have been yelling at me. That is not correct at all. It should have been 0.36. That is totally my bad. Yeah, 0.36. That was what it should have been. I'm so sorry. Yes. So 0.36 was the answer. So glad I got that. So again, the checking method wasn't ideal, wasn't perfect, but it's a quick way to kind of double check yourself. Yeah, so sorry. So the answer is, for the first one was 0.36. So for this one, when we do it, right, we end up with 1.34. And for z-scores, we typically get 2 decimals for the most part. There's one case where we don't, but for the most part, we just do 2 decimals. All right, and that's it. And of course, it does make sense for it to be 1.34. All right, now let's find the z-score separating the bottom 1% and the top 4%. So this one is tricky just because it is, so let's think about this. If we're trying to find a z-score, what are we going to type in? Is it normal CDF or inverse norm? Well, as you probably noticed, it's inverse norm, right? But if you notice, inverse norm only has two things: area, mean, standard deviation. Sorry, three things: area, mean, standard deviation. There's nowhere for us to put two things. So this is secretly two problems in one. This is two separate problems that it's asking. Because the trick is, if you're not paying attention, typically people see, oh, 1%, 4, that's normal CDF, right? Because it's low, high, mean, but that's not it at all, right? Because we know that's not what it's asking for. It's asking to find the z-score. So this is a trick because it's asking two different problems. So first, let's look at the bottom 1%. So it's a bottom percentage, perfect. So it's a z-score, so we know the bottom is 0. So if we go from the left all the way up to the mean, how far have we gone? Too far or not far enough? That's 50%. We only wanted 1%, so that's way too far. So we need to back it up. And we shade to the left. So this is where the 0.01 goes, because that's where the probability is. This is our data value that we're trying to find. So to find the data value, you put inverse norm, right? The area is 0.01 because that's to the left. The mean is 0. Standard deviation is 1. We type all that into the calculator, which I will definitely do now so I don't mess up again. We end up with negative 2.33. So let's think about this. Can that value go here? Can that value go right here? Yeah, right? It's below 0, so perfect. That's probably right. And it actually is. Yeah, y'all should have gotten it too. Now, let's look at the top 4%. So that's our first value. Let's look at the second value. So we have a top percentage. That's no go. We need to do the bottom, right? So if we're in the top 4%, what percentage are we smarter than? So hopefully you all saw it was 96, right? Just 100 minus 4, 96%. So this is what we're going to be doing, the bottom 96%. So we make our graph, put 0 in the middle, going from the left because it's from the bottom, and we go up to the mean. We've gone 50%, too far, not far enough. Not far enough, we got to keep going, right? Shade everything to the left. And this is where 0.96 goes. This is where our value needs to go. So to find this value, just again, do inverse norm. The area is to the left, which is 96%. Mean is 0. Standard deviation is 1. We type all that into our calculator. We end up with 1.75. Does that make sense? Yeah, right? It's positive. Makes sense. All right, and those are our two answers. All right, so last thing we got to talk about is percentiles, and then we can move on. So we already did talk about percentiles, right? If you remember, what did we say Q1 was? So we talked about quartiles first. Remember we said that was P25, which meant it was the 25th percentile. Right? Remember we said Q2 was the same as P50, which was the same as the 50th percentile, and so on and so forth, right? And if you notice, if you go back in your, so I think this was the 313, it was, if you go back to those sections, right, you'll see that what we said was it separates the bottom, this one separates the bottom 25%. This one separates the bottom 50%, right? If you remember, the way we separate those out, using those 5-number summaries, it was the min, Q1, Q2, or the median, right? Easier way of saying that. And then the maximum. So going from left to right, right? P25 is the bottom 25%. P50 is the bottom 50%. P57 or 75 is the bottom 75%, right? Because 25, 25, the whole thing is 50. 325s, whole thing is 75, right? All that to be said. So that was a long explanation for something very simple, which is this. If you have P alpha, right? So P with a number on it, that's just the bottom alpha percent. So it gives you the bottom alpha percent. So if we had P10, that's the bottom 10%. If it's P86, that's the bottom 86%. So it gives you percentage. Percentile gives you percentage. Makes sense, right? You want to know what is the value. So let's look at example number 5. P84 in standard position. So standard normal distribution. So standard normal, mean is 0, standard deviation is 1. So P84, so that means it's the bottom 84%. So draw our graph, middle is 0. So from the left, we go up to the mean, too far, not far enough. Not far enough. We need to go past the 50% mark. And then we put 84 right here, or 0.84 right here, right? Hopefully everybody is saying no, because probability goes up there, right? Data values go down here. That's what we're trying to find. We're trying to find that data value. So if we need to find the data value, we do inverse norm. Area is 0.84. Mean is 0. Standard deviation is 1. And we type all that into the calculator. We end up with 0.99, which makes sense because that is positive. All right. Let's do maybe one more. We'll see. So find the 27th percentile. The 27th percentile. So another way to say that is P25 or 27, right? And so the 27th percentile is just going to be the bottom 27%. So we graph it. It's still standard position, so 0. So if we come from the left, if we go to the mean, too far, not far enough. Too far, right? That's 50%. We only want 27, so we back it up. Shade to the left. Remember the 0.27 is going to go up top. We want the bottom. So inverse norm. Area is going to be 0.27. Mean is 0. Standard deviation is 1. So we type all that into our calculators. We should end up with a negative 0.61. Wait a minute, does that make sense? Can we have negative in this case? Yes, we actually can, right? Because remember, we're not talking about probabilities, we're talking about data values. Data value below mean just means below average. So since it's below 0, we actually would want a negative number. We would be incorrect with a positive number. Good. All right, so let's do some word problems. Hopefully you can follow along. I already typed these up and posted them to the website, so we can just follow along. These should, again, very easy. These should be the easiest word problems you've ever done, hopefully. We'll see. They should be the easiest word problems you've ever done in your life. All right, so the Tall Clubs International has a requirement that women must be at least 70 inches tall. Given that women have a normally distributed heights with a mean of 36.8 inches and standard deviation of 2.6 inches, find the percentage of women who satisfy that height requirement. All right, find the percentage. So what kind of thing are we going to do for normal distribution? We're going to do normal CDF, right? If it's find percentage, normal CDF. So We draw our graph. What goes in the center? So remember, it's not 0, it's the mean. And the previous example, 0 has been the mean. This time, we see that the mean is 36.8. So we want the probability, so we have to have a data value down here, right? So what's the data value that it gives us? So we have to read the problem to tell, but it says that to meet the height requirement, you have to be at least 70 inches tall. So 70 is our number, and the location is to the right, right? Because 70 is more than the mean. At least, what does that mean? Are we going to shade to the left or to the right? At least 70. So 70 is the least, and it has to go bigger than that. So this is what we need to find. So, since we're doing normal CDF, the lower is 70, the upper is 9999, the mean is 63.8, and what's standard deviation? 2.6, because it told us right there. When we type all that into our calculators, we end up with 0.0085. It did ask for percentage though, so if we convert that to percentage form, we end up with 0.85%. Right, just move those decimal over 2 spots. Which makes sense, right? That's a very small percentage. That's a, tall women's club. You should be pretty tall. Good. Next one. When designing aircraft cabins, what ceiling height will allow 95% of men to stand without bumping their heads? Men's heights are normally distributed with a mean of 69.5 and a standard deviation of 2.4. So now we are given a percentage. So the question is this a bottom 95% or is it a top 95%? So this is where the word problem comes into play, because you have to know from the context of the problem. You can't just say, oh, 95, that's a big number, it's the bottom, or 95, that's a big number, it's the top. No, it has nothing to do with 95. It has to do with what the problem is saying. So what do we know about these 95% of men? They have to stand without bumping their heads. So if you think about a ceiling height, who are the people who are going to be able to stand without bumping their heads? Is everybody that value or shorter, right? This value or shorter, which would mean a bottom percentage, right? Does that make sense? If you have a ceiling height and people who can't bump their heads, then everybody shorter than them, the bottom would have to be. Now, let's do a pause on this. And let's think about what would be an example of a top 95%. What could some examples of a top 95% be? Something where this is the value and everything above it would be what you would want. So something that I thought of was if you're standing in a pool, right? Standing in a pool without holding your breath. 95% of people, right? Yeah, screw those 5%. They have to hold their breath if they're underneath this, right? It could be something like, one of my students at one point said carnival rides. Right? You have those signs that say you have to be this tall, at least this tall or higher to ride the ride, right? That would be a top percentage. Yeah, so things like that. Doesn't have to be exact, but here's some examples, right? So again, it's from the context of the problem. You just have to read the problem. And I will say the majority of the time when students mess up word problems, it's because they have overwhelmed themselves and they say, oh no, a word problem in math, I can't do this, oh no, and they don't actually read it. So when you see a word problem, just breathe, take a deep breath in, deep breath out, and just read it, right? Most of the information is just there. And by most, all the information is just there for you. So all you have to do is just read it. All right, so unpause. Let's go back to this problem. So we know that it is a bottom 95% because it's people who are standing without bumping their heads. So we draw our graph, normal distribution. So what number goes in the middle? We see that it is 69.5. So bottom percentage, we come from the left. If we go up to the mean, too far or not far enough? Not far enough. We need 95%, right? It needs to go over half. So we shade everything to the left, and that's 95. And so this is what we're trying to find, right? No, because what goes up here? Probability. This doesn't make any sense, right? We already have probability. So hopefully I didn't fool you. So the 0.95 goes up here, and this is the value we want, right? That's literally the hardest part, just making sure you know which side that goes on. So we got inverse norm. Area is 0.95, because that's the bottom percentage. Mean is 69.5. Sigma is the standard deviation, which is 2.4. When we type all of that into the calculator, we end up with 73.45 inches. So just rounded one extra decimal place. That's it. Number 3, problem 3. So I think there's 2 more problems, but lots of parts. So hopefully we can get all the experience we need. So most live characters at Disney World, so these are the people wearing the costumes, looking like Mickey and Goofy and all those people, have a height requirement with a minimum of 56 inches and a maximum of 75 inches. Use the heights of men and women from a normal distribution from problems 1 and 2. So find the percentage of women meeting the height requirement. So if we go back, problem number 1, we said that the mean for women was 63.8 and the standard deviation was 2.6. So for women, we said mean 63.8, 2.6. Let me just double check because I was already wrong once. Don't want to be wrong again. Yeah, cool. All right. So we draw our standard deviation. What goes in the center? 63.8. What values are we given? We know it's a minimum of 58, which would be over here. Sorry, 56. Maximum of 75, which would go here. We want it between, right? If you meet the height requirement, you're between these two values. So how do we figure that out? We just do our handy dandy normal CDF. The lower is 56. The upper is 75. Mean is 63.8. Standard deviation is 2.6. Let me type all that in. We end up with 0.9986. So it said percentage of women, so we just changed that to a percentage. Should be 99.86%, right? 2 decimals over. Cool, cool. Now find the percentage of men meeting the height requirement. So going back to example number 2, men have a mean of 69.5, standard deviation of 2.4. So we draw our graph. This time, 69.5 goes in the middle. But if you notice, everything else is the exact same, right? The minimum is still 56, or sorry, yeah, 56. The maximum is still 75. So our graph still looks more or less the same. We just have a different mean this time. We still need to do normal CDF. The lower is still 56. The upper is still 75. The only difference now is the mean and standard deviation, right? The mean is 69.5. Standard deviation is 2.4. So when we type all that into our calculators, we end up with 0.9890, or as a percentage, 98.90%. Part C, if a new height requirements are changed to exclude only the top 5% of men and the shortest 5% of women, what are the new height requirements? All right, so remember, if it's percentages, what are we going to be doing using our calculator? If it gives us percentages, what are we doing in the calculator? We're doing inverse norm, right? Inverse norm only has 3 values: area, mean, standard deviation. There's not room for 2 numbers. So that means that these are 2 different problems. The tallest 5% of men, shortest 5% of women, excuse me. So let's look at the tallest 5% of men. So the tallest 5% of men, is that the top 5% or the bottom 5%? Hopefully you can see that's the top 5%, right? If you're the tallest, you're above everybody. However, right, do we want tops? No, we need the bottom percentages. So that's going to be the bottom 95%, which again, just 100 minus 5, 95%. All right? So for men, what number is in the center? 69.5. If we're coming from the left, because it's the bottom, go up to the mean. Too far, not far enough. Not far enough. Got to go all the way up to 95%. And where's the 95% going? Is it down there or up, down here or up there? Hopefully, since it was percentage, you said it was up there. 0.95. And this is what we're trying to find right there. So we do inverse. We do inverse norm. Area is 0.95. Mean is 69.5. Standard deviation is 2.4. And we end up with 73.45. Did we just do this problem? I feel like we've done this problem somewhere. Oh, yeah, top 95%, bottom 95%. We already did that problem. Okay, that's why that number looks so familiar. Okay, so if you were paying attention, you might have already known that without having to do all these extra stuff. And then lastly, the shortest 5% of women. So is that going to be a top percentage or a bottom percentage? Hopefully you saw that's the bottom 5%, right? Shortest. So we don't have to do anything extra. So for women, remember it is 63.8. Again, don't want to mess that up. So we said the women was, 63.8, 2.6 is the standard deviation. Good. So since the bottom 5%, if we come from the left up to the mean, too far, not far enough. Way too far. That was 50%. We need to back it up to 5%. Good. And where's the 5% going to go? Does it go down there or up here? It goes down or up? Hopefully you saw the percentage, so that goes up here. That's the 5%. That's the value we're trying to find. So we do inverse norm. The area is 0.05. The mean is 63.8. Standard deviation is 2.6. When we type that into our calculator, we get 59.52 inches. Which, if we can tell, right, this number is above the mean, which is good. Probably did it right. This number is below the mean, which is good. Probably did it right. Probably. Just a quick check. All right. Last problem, and then we are done with this video. Woo! All right. So again, you may be seeing a lot of words. Just slow down, take a deep breath out, and then let's just read it. So, a common design requirement is that an environment must fit the range of people who fall between the 5th percentile for women and the 95th percentile for men. In designing an assembly work table, we must consider sitting knee height, which is the distance from the bottom of the feet to the top of the knee. Males have sitting knee heights that are normally distributed with a mean of 21.4 inches and a standard deviation of 1.2 inches. Females have seating heights that are normally distributed with a mean of 19.6 inches and a standard deviation of 1.1 inches. So what is the minimum table clearance required to satisfy the requirement for fitting 95% of men? What is the minimum table clearance required to satisfy the requirement of fitting 95% of men? So first, is this and we'll do the last one, we'll do the next question last. Is this going to be a bottom 95% or a top 95%? So there's a couple different ways we can figure that out. First, so who are going to be using these work tables? If you have a work table, and I am not a drawer, are you going to be able to have a knee length that's bigger than that height or lower than that height? Obviously, if you're going to use it, you need to go underneath that desk, right? So it's a lower height. So this is a bottom 95%. Also, it already gave you the 95th percentile. What do we say percentile means? Bottom 95%. So two different ways of getting the same answer. So we look at the men, right? It just talked about for men. So we need a mean of 21.4. So we go from the left up to the mean. Too far, not far enough. Not far enough. Got to keep on going. Where's the 95% going? Hopefully you knew it was going up there. So how do we figure this out? We do inverse norm. The area is 0.95. Mean is 21.4. Standard deviation is 1.2. We type all that in. We end up with 23.37 inches. All right, so now, why is the 5th percentile for women ignored in this case? So, basically, the reason why it's ignored is because what we want here is we want to make sure of all the people who can actually fit underneath this, right? So if the bottom 95% of men, right, if the whole 95% of men can fit, definitely the bottom 5% of women can fit, right? So if we think about this, if this table can fit 95% of men, well, of course it's going to fit the 5% of women, right? The bottom 5% of women. Cool. And that was it. So we could say, if there is clearance for 95% of males, there will certainly be clearance for all women in the bottom 5%. Yeah, so that was kind of a little extra information we didn't really need to worry about. Just trying to trick us. All right, so the author is writing an example at a table with a clearance of 23 inches above the floor. So what percentage of men will fit in this table? So for men, remember we said the mean was 21.4 inches and the standard deviation is 1.2 inches. So mean goes in the center, 21.4. So we have a value 23.5. That's going to go above our mean. So here's the question. Who are going to fit under this table, right? Who's going to fit this table? Well, hopefully you remember we talked about if you're going to be able to sit comfortably at this desk, you're going to have to fit underneath this table, right? So a bottom percentage, that's going to be to the left. And this is what we need to find. So we do normal CDF. The lower is negative infinity, right? Goes all the way down, negative infinity. The upper is 23.5. The mean is 21.4. Standard deviation, 1.2. And when we type all that in, you should end up with 0.9599. And if it said what percentage, then that would be 95.99%. All right. Practically the last question. What about women? What percentage of women will fit? So if you go back and you can look, you can see that the mean seating height for women was 19.6. The standard deviation was 1.1. So practically speaking, it's going to be more or less the same thing. The only difference is that our center number is going to be different, right? Our value is still 23.5, right? It's still to the left. These are the people who can fit underneath it, right? We still do normal CDF. The lower is still negative 9999. The upper is still 23.5. The only difference is this time, well, didn't give enough space. So normal CDF, lower is negative 9999. Only difference now, like we said, is that the mean is going to be 19.6. Standard deviation will be 1.1. And when we type all that into our calculator, we end up with 0.9998, whereas a percentage, 99.98%. So last question. Does the table appear to be made to fit almost everyone? So we said that it was, for men, it was 95.99%. For women, it was 99.98%. So yeah, basically. So you could say the table will fit everyone, mostly, except for the top about 4% of men, right? Because that's almost 96%. So the only percentage of men that wouldn't be able to fit is about just 4%. And that's practically 100% right there for the women. Good. That's it. Hopefully you didn't find this too hard, but if you did, as always, practice. Email me or text me if you have any questions.